Greetings! We would like to present to you our project about Apache Storm and for the course Tools for Big Data. First, we will give an ultra short reminder of what week 8 and 9 was about. We will cover the weaknesses of using MapReduce job or message job and or Spark for data that changes often or has a streaming nature, how Apache Storm works, what spouts and bolts are, what our example is about, how our example works with a walkthrough of the source code, some example output, and how to cluster Storm and what the different components are. Yes. Week 8 we did an exercise about we were given a graph of friends from Facebook, and we were supposed to find out the mutual friends of each friend pair. And for this problem we used MapReduce, MR job to be precise, which is a Python library. We defined some mapping steps that were a text file and did mapped each edge in the graph and then reduced it into friend pairs, and then through that reduced it into lists of mutual friends. But the weakness in this approach is that the dataset is known beforehand and is static. So if we needed to find or add a new friend pair, we would have to recalculate the whole thing. And this wastes a lot of time, especially when you need the output real time. So yeah, what to do when our data frequently changes. We have a couple of different processing models here. We discussed the batch processing before. It is what the processing model of MapReduce, and Spark, which we used in week 9, uses this model, and also Hadoop MapReduce is also a MapReduce system. All data points are collected and processed in a batch. It is a group of data points which is known at the time it is put into the system. This is where Storm comes in. It is a stream processing system. We do not know the entire dataset beforehand, so we get data points one at a time, and they are streamed and processed by the system as they are given. Using streaming processing, we can add friends and see the data real time. There's also micro batch processing, which we will not be covering. Storm has this through Trident, and also Spark Streaming can also do micro batch processing. It just splits the batch up into smaller batches or collects stream points and gives it in small batches, one at a time. But what is Apache Storm? It is a general framework for real-time processing of streamed data points. It is programming language agnostic. So if the language runs on a Java virtual machine, it can be used with Storm. If it can be called from the command line, it will probably also be usable with Storm, like we did with Python. We used a library called StreamParse, which is an open source Python library posted on GitHub. Onto topologies, which is the main program definition for Spark. Storm. It is the structure of how the computations are supposed to be carried out. It is a graph where we typically have what we call a spout in the beginning. It is a spout is a node that reads in data and streams it out to one or more bolts. It can be It can be a message queue system or a database that is being watched or something else like that. We are using a text file which is just read in. And then the data is passed on to boats, which are the main, they are the nodes that carry out the computations. Between the nodes we have edges that is actually tuples of named variables. So the tuples are passed between the nodes. And on to our example. We would like to given a list of persons that are friends, we'd like to find the mutual friends, like in the exercise we carried out in week 8. Friend connections, they are built slowly over time, and if we have a look on the example graph down below, the red line indicates a new friendship being made, and when this new friendship is made, we have some computations that need to be carried out. So between the two persons connected by the red line, we have to make them mutual friends with the circled guys in the graph. So we don't want to run an entire map reuse operation every time a new friendship request is, or a friendship is made, because this will take a lot of time and the system probably won't be able to keep up. So the system should only update the relevant informations, and this is a good use case for Storm. We begin with by defining our friend spout, which is just reading a text file and outputs a tuple of friend A and friend B. It passes this tuple onto the first bolt, which will output. It will make a list and take the new friend pair that came into the system and outputting this friend pair and the friend that these two are a mutual friend of. It will pass this tuple on to the mutual friend bolt, which it keeps track of mutual friends and passes us our output. On this slide we have the source code for our spout, which is fairly straightforward. We have an initialize method, which is just setting an initial state when the program is booted up. We have a helper method, next friend, which is keeping track of a counter, and just a little convenient when we do logging for our big data set, because we have a lot of points and it will only yield or output every 5,000 point it registers. And then we have the next tuple, which is a method that is called by the Storm system when the next tuple is being processed, and it just reads in a new pair, a new friend pair, and emits this tuple for the next part of the system. And this is the source code for the friend spout. It has a small initialize method that just defines a dictionary where we will later put the friends. The process is being given a tuple as seen in the method header. It splits the tuple apart in a key and a friend. So the key is the person that has this friend, and if the friend is not already in the system, it adds the friend. If the key isn't already in the friends list, it adds the key and adds the friend to this person's friend list. And then for every friend in the list, this iter2's combinations method it outputs a combination of the friend list. So it outputs the first friend with the second friend, the first friend with the third friend, and so on. And then it emits this because they are, yeah, as you will see in this one, the next bolt. This is the last bolt. It takes it in a tuple with the friend pair and the friend they have in common. And this is fairly straightforward, as it is just adding the new mutual friends to the friend pair's mutual friend list. And then we have a random function that just decides when to actually do some logging, because the logging system will overflow if we just output everything, and it will be hard to keep track. And now we will run our program. Let's see. Just a second. Yes, for this we use the sparse run command, and it runs the program, which is of course in the folder. At first it will output a lot of messages for booting up the machines and the system. It will take some time because we have not started this system before. And now the processing is done. So you can see the friends are streamed into the system, and we have the two friends, and they have a mutual friend. And if we proceed, you can see at this point O and 1, they have 3 as a mutual friend, and down here O and 1, they have 2 and 3 as a mutual friend, and the same goes for O and 4. They have the same mutual friend up here. And at the end, O and 4 has the friends in common that are 1, 2, and 3. And this is also it is the same output as we got in week 8, exercise 3, I think. But in week 8 we also did the larger system with the Facebook list, and we have this system set up right here. The set takes about 30 seconds to go through, and we output every 5,000 friend connection, so everything else is just done in the background, but hopefully we will be able to follow what's actually happening. Yeah. So we can see how mutual friends are added to the list, and at some point this will probably tell us that the 5,000 elements, 5,000 elements have been yielded so far. Now we read in the entire file as fast as we can, but when the processing of this set is over, we can actually put in some more data to the system, and it will use this data to just keep on computing new friends. But yeah, this was the example of our running program. And if we continue, we'll talk a bit about how to cluster Storm, because of course when you are dealing with big data, you usually would like to cluster your computing nodes so that you can carry out computations way faster, and also keep the systems up. So if some of the nodes are crashing, then some other node will carry on the computations. Storm works in the way that it needs a Nimbus master node and some supervisor nodes that are the worker nodes of the system. And between these two types of nodes, we have some zookeeper nodes, which acts as a pure communication layer between the master node and the supervisor nodes. Zookeeper will make sure that if some of the nodes are crashing, they will get restarted and reconnected with the system, and some other node will carry out the computations instead. And another smart thing about Storm is that you can plug it into to your system if you have some services running already. Usually you start out with some kind of queuing system, message queue system, like Kafka, which is also an Apache project, Kestrel or RabbitMQ. You are able to store some of the data, typically in some sort of NoSQL database like Redis, Cassandra, Riak, or maybe a relational system like MySQL. And you will even be able to collect the data into batches and carry out some MapReduce operations on it if you would like to do that using like Hadoop or Spark. And that was it.